Okay, today we will discuss the new topic, that is ion exchange method. This ion exchange method, which is also called as demineralization method, ion exchange method, which is also called as demineralization method. See, why purification of the water is essential? Because in purification of the water, we can remove the impurities present in the water sample. So water becomes hard in nature due to presence of what? Calcium 2 plus, magnesium 2 plus, zinc 2 plus, right? So this kind of the impurity, it can be removed by using two different techniques, that is internal treatment and external treatment. In external treatment, there are two ways, that is zeolite method, and the second one is what? Your ion exchange method. Only one drawbacks in the zeolite method is zeolite containing what? Na2Ze, right? This is the zeolite, sodium aluminum silicate. Okay, and this sodium atom is loosely attached and it can be easily replaceable with what? Calcium 2 plus and magnesium 2 plus ion. And the exhausted zeolite is again regenerated by backwashing with what? 10% NaCl solution, right? But whatever the water is obtained after the treatment in the zeolite plant, that water containing what? Sodium type of the impurity, right? So that sodium type of the impurity cannot be removed with the help of zeolite method, and that can be removed with the help of what? Ion exchange method. You remember this one, right? So ion exchange method or demineralization procedure, your hard water containing what? Both the type of ion. Which one? That is cations as well as anions, right? So these both the types of the impurity which is present in your water sample, cations as well as anions. And for the removal of both the type of the impurity, we can use what? Ion exchange method can be useful for the removal of what? Both the type of the impurity. Now there are two different types of synthetic resin which is useful. The first one is, that is your cation exchange resin, cation exchange resin, which is denoted by RNH2, and the second one is anion exchange resin, anion exchange resin, which is denoted by R-OH twice, right? So these are the two different types of synthetic resin which is used for removal of what? Both the type of ion, that is cations as well as anions. Now we will see the first one, that is cation exchanger resin. The first is cation exchanger resin. This cation exchanger resin, the cation exchanger resin having what? Carboxylic group or sulfonic group in their structure, so that it can be easily replaceable with what? H plus ion. You remember this one. The cation exchanger resin having what? Carboxylic group or sulfonic group in their structure, so that it can be easily replaceable with what? H plus ion with cations present in your water sample. A common cation exchanger resin which is frequently used in the industry, that is what? Your styrene divinyl benzene copolymer. So this styrene divinyl benzene copolymer undergoes carboxylation reaction or sulfonation reaction, right? So which is readily or replaceable with what? H plus ion. The structure of this copolymer is like this: CH2 bond CH, and at para position sulfonic group SO3 minus H plus CH2 CH, again at para position carboxylic acid group COO minus H plus. Or in short, this is represented by what? Yes.
RH2.
Yes, very good. It is represented by RH2, right? Now, what is the speciality of this RH2? It can be easily replaceable. So, twice H plus ion is easily replaceable with what? Cations. Which types of cation? Calcium 2 plus, magnesium 2 plus, Na plus, right? For that, this is the speciality of what? Your cation exchanger resin. See, I will again repeat the cation exchanger resin. The cation exchanger resin having what? Carboxylic group or sulfonic group, right, in their structure, and so that it can be easily exchange what? H plus ion, right, with what? Cations present in your water sample. So therefore it is known as what? Cation exchanger resin. A common cation exchanger resin frequently used in industry is what? Styrene divinyl benzene copolymer, and this is the structure of what? Your styrene divinyl benzene copolymer. It can undergoes what? Carboxylation reaction or sulfonation reaction, right? This is the structure, or in short we can represent this structure like this: RH2, right? So this is called as what? Your cation exchanger resin. Now the second type of resin which is used in the ion exchange method, that is what? Your anion exchanger resin. Second number is anion exchange resin, which is denoted by what?
R dash
R dash
OH2.
OH.
RH2.
Yes, very good. Which is denoted by R dash OH twice. See, the anion exchanger resin having what? Basic group. Which one? That is quaternary ammonium group in their structure, right? And on the treatment with what? Sodium hydroxide, NaOH, right? So on the treatment with what? Sodium hydroxide, it can obtain what? OH minus ion as an integral part of this structure, right? So hence this OH minus ion is easily replaceable with what? Anions present in your hard water sample, right? See, this is the structure of quaternary ammonium group at para position, styrene divinyl benzene copolymer, and at para position quaternary ammonium group. This is N3 plus OH minus, this is CH3 thrice, right? So this is the structure of whatever anion exchange resin, or in short we can represent this structure like this: R dash OH twice, R dash OH twice, right? Now, for preparing the deionized water, what is deionized water? Your water becomes free from what? Cations as well as anions, right? This is known as what? Deionized water. So for preparing the deionized water, your water first of all pass through the chamber of what? Your cation exchanger chamber, followed by what? Anion exchanger chamber, right? See, the simple schematic diagrammatic representation which is mostly used in the industry, the two different chamber. This is the first chamber, that first chamber containing what? Your cation exchanger resin, right? And in second chamber anion exchanger resin is kept, okay? And first of all, your water you have to pass into what? Cation exchanger chamber, followed by what? Anion exchanger chamber. So in this chamber RH2, and in this chamber R dash OH twice, right? So this is the simple schematic diagrammatic representation for preparing what? Your deionized water, right? Deionized water means your water becomes free from what? Cations as well as anion. So this is deionized water, right? And from this top of the chamber you are going to pass the hard water, that hard water containing what? Cations and anions. So here is what? In this chamber cation will be trapped, and in this chamber anion will be trapped, and this is what? Your deionized water means what? This water becomes free from the both the type of the impurity, that which one, that is cations as well as the anions. Now reaction at cation exchanger chamber. Suppose reaction at cation exchanger chamber, reaction at cation exchanger chamber. In case, suppose sodium chloride, calcium chloride, magnesium chloride, magnesium sulfate, this kind of the impurity, if it is present in your water sample. So this is RH2 plus twice Na plus, right? So if sodium is present in your water sample, then what happen here is sodium will be trapped, right? So it can form what? RNA2 plus twice H plus, right? Means your water becomes free from the impurity. So here is what sodium kind of the impurity will be trapped in this chamber. In case calcium 2 plus, right, RH2 plus calcium 2 plus. So what happened here? Yes.
RC
Yes. RCA plus
plus twice H plus.
twice H plus. Suppose in case magnesium 2 plus impurity is there, then it can form
RMG plus twice H plus.
yes, Rmg plus twice H plus ion, right? So here is what replaceable is what twice H plus ion with sodium, calcium and magnesium, and this RNA2, RCA and Rmg, this will be the species which is trapped over here, right? Means your water becomes free from what cations type of the impurity. What is left? Anion is the left, right? Now in the second stage, reaction at anion exchanger chamber, anion exchanger chamber. So in anion exchanger chamber, anion, that is what your R dash OH twice, right? This is the anion. Sorry, anion exchanger resin. So R dash OH twice plus, suppose chloride, R dash OH twice plus SO4 minus minus sulfate is there. Now predict the product. What happened here is twice OH minus ion is the replaceable with anion. So it form what?
R dash Cl2.
Yes, very good. R dash Cl2 plus twice OH minus ion. And in this case,
R dash
R dash
SO4
SO4.
plus
So 4 twice OH minus.
yes, very good. R dash SO4 plus twice OH minus ion. In short, your water becomes again free from what? Cations as well as what? Anion, right? But what happened? Due to continuous washing, your cation exchanger chamber and anion exchanger chamber, it get exhausted. Their regeneration capacity is reduced. Why? Because RNA2, RCA, RMG, this is the species exhausted in this cation exchanger chamber, and R dash Cl2, R dash SO4, this is the exhausted species in whatever anion exchanger chamber, right? Means finally your water having practically no ion, means it is what? Ion free water which is obtained, right? So this is called as what? Deionized water, right? See, the H plus ion in cation exchanger resin, right? And OH minus ion in anion exchanger resin, right? So it get exhausted. H plus ion in cation exchanger resin and OH minus ion in anion exchanger resin, it get exhausted after some times, right? Due to continuous washing of what? Your hard water that containing either either cations or anions, right? So for regeneration of cation exchanger resin, we can use hydrochloric acid, HCl, or sulfuric acid H2SO4. You remember this one. For regeneration of cation exchanger resin, dilute HCl or dilute sulfuric acid can be useful, right? See, for example, this is the exhausted species RNA2, RCA and RMG, right? So these are the regeneration reaction RNA2, RCA, RMG, right? Plus it can be regenerated with the help of dilute hydrochloric acid or sulfuric acid. So twice HCl, twice HCl, twice HCl. Now predict the product. What happened here?
RH2 plus twice RH2 plus twice NaCl.
Yes, very good. It form RH2 plus twice NaCl sodium chloride. Means our resin is regenerated back, right? Without replacing the cation exchanger resin, we can regenerate number of times. In second case, what happened?
RH2 plus
twice
CaCl2.
Yes, RH2 plus CaCl2, calcium chloride. And in this third case,
RH2 plus MgCl2.
yes, RH2 plus MgCl2. So it form RH2 plus MgCl2. Is that clear? Regeneration reaction? Yes? Yes?
Yes, sir.
Yes, sir.
Now, in second case, in anion exchanger resin, this R-Cl2 and R-SO4, these are the exhausted species is formed. So dilute NaOH, in this case, dilute NaOH, sodium hydroxide, right, which is slowly passed through the anion exchanger chamber and your resin can be regenerated. Now the regeneration reaction at anion exchanger chamber will be like this: R-Cl2, R-SO4 plus twice NaOH, twice NaOH. Now predict the product. What happened here? Yes.
R-OH2 plus twice NaCl.
Yes, very good. R-OH twice plus twice NaCl, sodium chloride. And in here is
R dash
R-OH2 plus twice NaSO4.
not twice, only Na2SO4, right? R-OH twice plus Na2SO4, sodium sulfate. In this way, we can regenerate anion exchanger resin, right, by number of times. Understood up to this point?
Yes, sir.
Yes, sir.
See, why we are going to pass hard water first of all in cation exchanger chamber, and then we can pass into the anion exchanger chamber. Why not first of all hard water is passed into the anion exchanger chamber followed by cation exchanger chamber, right? The sequence is what? Hard water is passed into what? Cation exchanger chamber followed by what? Anion exchanger chamber, right? So why vice versa is not possible, we will see, right? Suppose reaction in cation exchanger chamber, reaction in cation exchanger chamber, reaction in cation exchanger chamber. For example, calcium bicarbonate if present in your water sample, CaH CO3 twice. This is calcium bicarbonate is present, and this calcium bicarbonate comes in contact with what? RH2 means what? Cation exchanger resin. So it can form what? RCA, right? Plus twice H2CO3. Here is what? Carbonic acid is obtained. You remember this one. Calcium bicarbonate comes in contact with cation exchanger resin. It forms RCA plus carbonic acid is obtained. Again, suppose magnesium chloride MgCl2 plus RH2, right? So it can form what? RMg, right? Plus twice HCl. Here is again hydrochloric acid is formed. Here is what? Calcium sulfate is there and comes in contact with what? RH2, right? So it can form what? RCA plus H2SO4. Means what happen during the treatment of cation into the cation exchanger, the acidic type of impurity is obtained. You remember this one, right? This acidic type of the impurity is obtained, and this acidic type of the impurity which is trapped into what? Anion exchanger chamber, right? So in second case, this is the impurity, actually carbonate, chloride, sulfate, these are the anions, right? So then this water is passed into the anion exchanger chamber. So the reaction in anion exchanger chamber which is going to take place like this. So in anion exchanger chamber, what is present? R dash OH twice, R dash OH twice, right? Plus twice H2CO3, this one carbonic acid. Second is R dash OH twice plus hydrochloric acid twice HCl, and third is what? R dash OH twice plus H2SO4 sulfuric acid, right? Now, so here is in anion exchanger chamber, the reaction will be like this. It can form what? Your R dash CO3 plus twice H2O. Here it is form R dash Cl2 plus twice H2O. Here it is form R dash SO4 plus twice H2O. So this is the reason your hard water is passed into first of all in cation exchanger resin, followed by what? Anion exchanger resin, because during the treatment here is it form acidic impurity, and that acidic impurity can be removed in anion exchanger chamber. Okay, understood this point? Yes.
Yes, sir.
For example, if your water containing calcium chloride, you can predict this one. See, calcium chloride, CaCl2, this kind of the impurity is present in your water sample. This comes in contact with what? RH2. Now, what is happening here? Predict the product.
RCA plus twice
RCA plus
HCl.
HCl.
Yes, very good. It can form RCA plus twice HCl, right? Now, in second case, this hydrochloric acid is useful for the regeneration, right? So, RCA plus twice HCl, it converted into what? Now predict.
RH2 plus CaCl2.
Very good. It form RH2 plus CaCl2, right? Okay. For example, magnesium bicarbonate is present, or magnesium bicarbonate, suppose if it is present, MgHCO3 twice magnesium bicarbonate plus RH2. Now predict the product. What is happening? It can form what?
RMG plus twice
RMG
H2.
plus twice H2CO2.
Yes, very good. RMG plus twice H2CO3, carbonic acid, right? Twice H2CO3. Now this RMG regenerated by hydrochloric acid, twice HCl. It can form what?
RH2 plus MgCl2.
Very good. It can form RH2 plus MgCl2, right? So understood this regeneration reaction? Yes.
Yes, sir.
Okay. Now, in ion exchange method, what are the advantages of this ion exchange method? See, the advantage of ion exchange method is, in ion exchange method, the water which is obtained, right? So that water having what? Zero hardness. You remember this one. Advantages of ion exchange methods are water obtained having what? Zero hardness, right? Then this second advantage is what? In ion exchange method, your water becomes what? Free from all types of the impurity. That is what? Your cations as well as what? Anions, right? And the third advantage is, in this process, the equipments which is occupy very small space, right? So these are the advantages of what? Your ion exchange method, right? What are the advantages of ion exchange method? The water obtained which is having what? Zero hardness. Then water which is obtained free from all types of the impurity, that is cations as well as anions. And the equipments, it can be occupy very small space, right? And one more advantage, it is very easy process. This ion exchange method is very easy to operate, right? So these are the advantages of what? Your ion exchange method. Okay. Now, only limitation of these techniques are, first one is their initial investment is very high. This is one of the limitation. And the second is, this method we can operate at only small scale purification of the water, right? It can be only applicable for what? Small scale purification of the water. So these